Lovely. I've never heard that before. It must be a new Zoom thing. Welcome everybody to today's session on exponents, which we have especially organized with Gamma Education Technologies. They really do some really fantastic video tech, and I'll leave Amazing to explain more about that. So Amazing is going to be your host. Well, we're co-hosting. I'm here to look pretty, and Amazing is here to do all the hard work. And I'm not even doing a great job of looking pretty. So there's that. So just while we're waiting for everyone just to join in, because I know technology can sometimes be a challenge, why don't you in the chat pop where you're from? So Amazing, where are you guys? You're based in Durban, right?
No, we're actually based in Johannesburg.
Oh, you muted again. Where's everybody else from? Arlene, where are you joining us from? You can just pop it into the chat. So if you have any questions, pop them into the chat. I'll monitor the chat and then just jump in where I feel like Amazing can answer any questions for you. Otherwise, pop them into the Q&A function. Gillian is from Pretoria. Awesome. Thanks, Gillian. So I'm going to hand over to Amazing now. Are you all set on your side, Amazing? Are you good? You ready? I don't know. All righty. Amanda, are you guys good on your side? Are you ready to take over? Hey guys, it looks like it's my internet. That's a pain. All right, Amazing. Are you ready on your side?
Oh, yes.
Awesome. Okay, I'm going to hand over to Amazing then. And then guys, if you have questions, I'll watch the chat function and just jump in with Amazing when I see it's a good time to ask the question. All right, handing over to you, Amazing. Have fun.
You're right. Thank you. Welcome to everyone. My name, as you heard, is Amazing Bandra, and I'm coming from Gamma Education Technologies. We are basically an educational tech company based in Johannesburg. That's where our headquarters are. And we are currently working with 100 schools from 2 different districts, 50 from Umzinyathi district and 50 from Utsugela district. So we've came up with this device called the Gamma stick. So the stick has contents which is kept aligned, and also has a lot of other things like videos, textbooks, and apps. There's a lot of fun apps there also. So today we'll be watching one of the videos that our content team and production team came up with. So I'll just play that video and we will just watch it. And if you guys have questions, I'll be happy to answer them. So the video is basically broken down into sections. We have our introduction, we have our sequential table. Our sequential table will tell us basically what we did in our previous grade, what we're doing currently, and what we'll be doing in our next grade. It also has recap. This recap is basically to recap on the prior knowledge of the kids. And we have lesson objectives, what outcomes are we willing to achieve at the end of this video, and then the lesson. And then we have real life examples, or I forgot about real life examples. So for kids to actually relate to what we're talking about, we have real life examples. That's a fun animation that the production team do to relate the lesson with real life. And then we have a quiz, which is basically summing up everything from what we learned. So just if you understand or didn't really understand, we do the short quiz. So it's a quiz and then answers, and then after that, it's a summary of the whole lesson. So today's video is actually quite short. It's not really long. The reason why we choose to do short videos is because we did a study on focus and time span. So we did a short for learners to actually don't lose focus and actually engage in the lesson. So I'll now share my screen and I'll play the video. Okay, there's no sound. Let me just share again.
Welcome grade 10s to our maths lesson. My name is Amazing Banjwa and today we are doing exponents, whereby we'll be simplifying using exponential laws and definitions. Now the resource we'll be using is the gamma device, and if we go to our textbooks, we will find a new solutions textbook, and in there we need to find 10.06, which is titled exponents. Let us now look at our sequential table. We will be looking at what we did in our previous grades, what we'll be doing currently in this grade, and what we'll be doing in our next grades. Now looking back, in our senior phase we did the 4 laws of exponents. We also simplified expressions using the laws of exponents. Now in this grade, which is grade 10, we'll be looking at the 4 laws and the 2 definitions of exponents and simplify expressions using the laws of exponents. Now, in grade 11 and in grade 12, we'll be simplifying expressions and solving equations using the laws of exponents and rational exponents. Let us now do a quick recap. Now, looking at this expression, the 2 is our coefficient. Now, the coefficient is the number in front of a variable. Now, looking at x, the x is the base. The base is the number of variable raised to an exponent. Now looking at the 3. The 3 is the exponent, the number of times you need to multiply a base by itself. Now this whole thing is called a power. Let us now look at a real-life example of exponents. Ever since Corona started, Custer never took it seriously. He went about his way disregarding the people around him, until Custer got infected, and then he infected 2 of his friends. And 2 of his friends infected 2 others, and so on and so on. Now, representing this mathematically, we can see that level 0, that's when 1 person was infected. Level 1, that's when 2 people were infected. Level 2, 4 people got infected. Level 3, 8 people. Level 4, 16 people. So as you can see that this shows an exponential growth of the COVID infection. Let us now look at our 4 laws plus the 2 new laws that we are going to learn. So law 1 states that when the bases are the same, we keep one base and we add the exponents. Say we have x raised to m times x raised to n. That will be equal to x raised to m plus n. So that means that we add our exponents. So let's look at a worked example. If we have 2 raised to 3 times 2 raised to 4, since the bases are the same, we keep one base and then we add our exponents. So we'll have 2 raised to 3 plus 4. So adding 3 and 4, that will give us 7. So we'll have 2 raised to the power 7. And our answer will be 128. Law 2 states that when dividing powers with the same base, we keep one base and we subtract the exponents. So if we have x raised to m divided by x raised to n, that will be equal to x raised to m minus n. So looking at a worked example, we will have 2 raised to 5 divided by 2 raised to 3. Since the bases are the same, it means that we'll keep one base and then we'll subtract the exponents. So doing that, we'll have 2 raised to 5 minus 3, which will be equal to 2 raised to 2, because 5 minus 3 is 2, and our final answer would be 4. Let us now look at law 3. When one base shares 2 exponents, we keep the base and we multiply the exponents. So if a power is raised to a power, if we have x to the power m, all raised to the power n, that will be equal to x raised to the power m times n. Now looking at a worked example, we will have 3 to the power 2, all raised to the power 3. Now, since we have 2 and 3 as exponents, we'll multiply those two exponents together. So we will have 3 raised to the power 2 times 3, and 2 times 3 will give us 6. So our answer will be 3 to the power 6, which will be equal to 729. Now moving on to law 4. When two different bases share an exponent, we raise each base to the exponent. So if we have ax, all raised to the power m, that will be equal to a to the power m times x to the power m. So looking at a worked example, if we have ab, all raised to the power 5, our answer will be a to the power 5 times b to the power 5. So that's our answer. Let us now look at the two new laws that we are going to learn about today. Now, law 5 states that a base that is raised to a negative exponent is equal to its reciprocal raised to the same positive exponent. So if we have x raised to the power negative m, our answer will be 1 over x to the power m. Because remember that every term is over 1, so writing the reciprocal of x to the power negative m over 1, that will be 1 over x to the power m. So we do away with the negative sign. Let's look at a worked example. Say we're given 2 to the power negative 3. So what we'll do is we'll write the reciprocal of that, which will be 1 over 2 to the power 3. Remember, we remove the negative sign. Let us now look at law 6. Law 6 states that any base that is raised to a power of 0 is equal to 1. So if we have x raised to the power 0, our answer is 1. Looking at a worked example, if we have 2 to the power 0, our answer is 1. Let us now do our quiz. Simplify the following expressions. For a, we are given x to the power 3 times x to the power 4. And for b, we are given b to the power 5 over b to the power 2. For c, we have 1 over x to the power negative 2. And for d, we are given 5x to the power 3 all to the power 2. Now for e, we are given 1 over 2 all to the power 0.
So basically at this part, kids can just pause the video and do these 5 questions, and then after this 1 minute countdown, they'll actually check their answers. So I'll just fast forward to the answers.
Let us now look at our answers. For a, we are given x to the power 3 times x to the power 4. Now here we can see that our bases are the same, so we can add our exponents. So by doing that, we will have x to the power 3 plus 4. 3 plus 4 would give us 7, so we will have x to the power 7. Now let us move on to b. b, we were given b to the power 5 over b to the power 2. So since we're dividing numbers with the same base, we will keep the base and we'll subtract the exponents. So we will have b to the power 5 minus 2. So 5 minus 2 is equal to 3. So our answer will be b to the power 3. Let us now move on to c. C is given as 1 over x to the power negative 3. So here, our denominator has a negative exponent. So since we have that, we are going to change that exponent to being a positive. So we're going to reciprocate the fraction. So we will have x to the power 2, which is a positive 2. Now let us look at D. D is given as 5x to the power 3 all to the power 2. So there we can see that 2 needs to be distributed to both the numbers. So doing that, we'll have 5 to the power 2 times x cubed all to the power 2. So 5 squared is equal to 25. And since we have a power raised to a power, we are going to multiply those exponents. So 3 times 2 is equal to 6. So we will have 25x to the power 6. That's our answer. Now moving on to E. E is given as 1 over 2 all to the power 0. So if we remember, any number raised to a power 0 is equal to 1. So our answer here is going to be 1. Now let us do a quick summary of this lesson. Now law 1 states that if you're multiplying bases that are the same, we will keep the base and we will add the exponents. Law 2 states that if we're dividing numbers with the same base, we will keep the base and we will subtract the exponents. Law 3 states that if we have a power that is raised to a power, we need to multiply the exponents. Law 4 states that if we have two bases that share one exponent, we need to distribute that exponent to each of those bases. Law 5 states that if we have a number that is raised to a negative exponent, we can reciprocate and remove the negative sign. Now, law 6 states that if we have a number that is raised to the power 0, that answer is equal to 1. Now, remember, grade 10s, to consult the Gamer textbook. On page 10, you will find exercise 6, and page 11, you'll find solutions. Past papers and additional exercises are recommended. Attempt as many as possible other similar examples on your own. Compare your methods with those that were discussed in this video. Repeat this procedure until you're confident. And do not forget that practice makes geniuses. So that's it, grade 10. See you again in our next video, where we'll be doing exponential equations.
So yes, that is basically the end of our lesson. And I guess I'm open to questions, and yeah.
Awesome. Thanks so much. Amazing. Guys, are there any questions on this topic for Amazing today? Anybody have any thoughts? Just pop them into your chat or your Q&A. We have a very quiet group today. Amazing.
Yeah, because basically we just looking for feedback, good feedback, bad feedback, on how to improve, what to add, what not to do, and because this is basically a video that was randomly picked from the other videos that we've done, and yeah, I would really like feedback on the work that we've did so far.
Awesome. Yeah, guys, any suggestions, thoughts, extra examples that should have been included? We'll just give it a minute because typing takes a while sometimes.
Okay, no problem.
There you go. Marlene says, amazing, did an amazing job. You were very clear. So your feedback is very positive.
Thank you.
Awesome. Thanks, Marlene. Cool. It looks like you did such a good job. There are no questions. Oh, hang on, there's a Q&A. Jillian wants to know, how many questions do you have in the textbook for the kids to do?
Okay, I just was the topic. Normally it's 5 or more, but the topic differs depending on the topic, and the answers are also on the textbook. So on the video, we normally do three examples. Yeah, three examples, and then on the quiz, we normally do 3 or 5 examples. Just trying to include every different type of examples there is.
Okay, that makes sense. So one from every problem area.
Yes, basically.
Okay, awesome. Thanks. Okay, guys, any other questions that you want to add there? I think we've missed the students, so usually during the evening sessions, they tend to be more vocal. All right, fantastic. Great. Is there anything else you'd like to share with us? Amazing. Where can we get one of these GammaTech sticks?
The Gamma devices at the moment they're basically a pilot process. So we're currently working with those 100 schools. So they are the schools that currently have these Gamma sticks. For more information, I think you can just contact our details, our headquarters, and then from there you can just get every other information that you need.
Okay, great. Amanda, won't you pop your email address or your website into the chat function for everybody so that they can see where to visit? And then Kristen says, would we be able to get access to these videos at a later stage to rewatch? So Kristen, this video has been recorded. So this particular one, yes, you will be able to watch on the Maths YouTube channel. So yes, but for GammaTech, I think you need to visit the website. And then Chantal has asked, is Gamma available for schools only, or can individual school learners also get it? Amazing.
Yes.
Can individual learners also get GammaTech, or is it only for a school situation?
Okay, can you please repeat that? I missed because it was glitchy. Can you repeat that question?
No worries. So Chantal has asked, is it only for learners? Is it only for schools, or can individual learners also get the GammaTech stick for their specific grade or topic?
Okay, currently it is still for schools currently, but at a later stage, we would like to have every learner to have his or her own Gamma stick, because it has everything there. So imagine if a kid has this Gamma device and from grade 1, so using the Gamma device from grade 1 up until grade 12. So basically that's our main goal. We want to have everything. We want to have the kids to have the device individually. So currently, to answer the question, no, it's not available for individual learners, but for schools, it is available.
Okay, awesome, fantastic. And then Amanda has popped into the chat both her email address where you can contact her and the website where you can go and visit. When I email you guys on Monday, I will also send these links again so that you can chat to Amanda directly about any questions that you might have as well. Okay. Any other questions? Are we all happy? Have all the answers? All right, guys, let me stop recording here. To those of you who are watching us on YouTube, thank you so much for joining us. We do appreciate your time, and we look forward to seeing you again.